Good morning. I'm on site here at Embedded World 2024. It's good to be back. And I'm pleased today to be joined by Dhiraj Sogani, who is the Senior Director for Wireless Product Marketing at Silicon Labs. So thank you very much for joining us today. It's a pleasure to have you.
Thanks, Paige.
Now today we're going to be talking about Wi-Fi and your new Wi-Fi 6 SoC. But before we get started, can you just give us a brief introduction to yourself and your background?
Absolutely. Yeah. Thanks a lot, Paige, first of all, for having me here for this conversation. I'm really excited to be at Embedded World. It's one of my favorite shows. A lot of interesting customers, a lot of interesting partners. Certainly, we tend to meet over here, so which is pretty nice. And the topic today that you've chosen is also perfect. That's kind of near and dear to my heart. That's a Wi-Fi topic. I've been in the wireless industry for almost about 15 plus years now.
Yeah.
Okay, and specifically working on all different kinds of wireless technologies: Wi-Fi, Bluetooth, ZigBee, Z-Wave, GPS, UWB, so name it. So I've kind of been working on that. So that's pretty close to my heart. At Redmi, in fact, at Silicon Labs, I've been kind of working on the marketing side a lot more. At present, I'm responsible for all product marketing activities as part of the industrial and commercial business unit of Silicon Labs.
Fantastic.
So really excited to be here. Thank you.
Fantastic. So you're the perfect person to talk to then about this new SoC.
Thank you.
But for those of us that don't know, can you give us a bit of an introduction to Silicon Labs as well as a company?
Sure. Silicon Labs is the leader in the wireless IoT space. In fact, not just wireless as well as compute right now, right? So, and again, we have a very broad portfolio of all the wireless technologies, all the devices. So we have Wi-Fi solutions, we have Bluetooth solutions, ZigBee, Z-Wave, right? So we have Matter solutions as well. So we always try to stay on the leading edge of all the wireless technologies which are required for the IoT devices. And in fact, all of the technologies that we have, all the devices that we have, they're very high security, ultra low power. They're very easy to integrate as well. So really, we are a single stop solution for all the IoT designers' wireless connectivity needs.
Fantastic.
Okay, and that's really what we strive to do day in and day out. We want to stay on the leading edge, bleeding edge to satisfy the requirements of the IoT designers.
Brilliant. Now, before we deep dive into the product, let's talk a little bit more about Wi-Fi 6. So what are the fundamental differences between Wi-Fi 6 and its predecessors?
Sure. In fact, rather than Wi-Fi 6 as a broad thing, so what I really want to do is maybe narrow it down a little bit to the IoT devices.
Okay.
Because Wi-Fi 6 is used for cell phones, laptops, set-top boxes, routers, switches, a lot of things, IoT devices. So the requirements tend to be different, differences tend to be different. So let me just focus on the IoT side of things.
Sure.
What is the difference between Wi-Fi 6 and Wi-Fi 4? So the biggest issue with Wi-Fi 4 was really when you're talking about 2.4 gigahertz spectrum, it's a very crowded spectrum. So Wi-Fi 4, the number of devices used to get restricted. So because more and more devices are getting added in the home environment, for example, right? You have security cameras, you have bells, you have, of course, phones are there, you have sensors all over the place. Everything is using wireless, and that was causing a lot of congestion.
Yeah.
So because of that, a lot of people could not keep on adding devices. Now with Wi-Fi 6, you can add a lot more devices in the home in the same 2.4 gigahertz environment. So that's a huge thing for us, right? Beyond that, of course, Wi-Fi 6 adds a lot of features. It increases the throughput, it reduces the power consumption, increases the range. So from IoT device point of view, this is a perfect solution right now. So IoT devices started off with Wi-Fi 4. They skipped a generation. Most of the IoT devices today don't use Wi-Fi 5. So from Wi-Fi 4, they are directly going over to Wi-Fi 6.
Yeah.
So, and specifically what we are seeing is earlier people were looking at 5 gigahertz spectrum because 2.4 gigahertz was becoming crowded in Wi-Fi 4, but they don't have to do that anymore. With Wi-Fi 6, with this additional capability of combining multiple devices at the same place, what you can really do is continue operating 2.4 gigahertz. That way you get lower cost, lower power, longer range, okay, and in fact you can have multiple devices coexisting. So this is perfect, I would say, for IoT devices.
Yeah. And what about sort of the security improvements? What does Wi-Fi 6 offer there?
In fact, Wi-Fi 6 has made a lot of security improvements over Wi-Fi 4 and Wi-Fi 5. So starting off with, let's say, WPA3. So that's one of the things which is wireless protected access, which has been made mandatory in Wi-Fi 6. That's something which is very important. Beyond that, they have added a lot of capabilities. There are a lot of acronyms. There's one RFS, SAE. We'll not go into the acronyms over there. But what they really do is, let's say, for example, somebody's trying to hack your system. And somebody has been able to hack the encryption key. But because of RFS coupled with WPA3, that person will not be able to really decrypt the old data. So that's an interesting one.
Yeah.
Then with the SAE, what you can really do is it replaces pre-shared key exchange. That's what it does. So that way the key exchange mechanism becomes a lot more secure. So from a security point of view, Wi-Fi, what they've been doing is kind of adding to the security every generation. And Wi-Fi 6 is no different. It has added to a lot of stuff.
Yeah.
Absolutely.
And how does it sort of address the increasing demand for data in industrial and consumer applications?
Yeah, so again, data is one of those things where things keep on, people want more and more throughput.
Yeah.
That's just the part of life, right? So, in fact, if you look at Wi-Fi 4, you could get up to 600 megabits per second. Not that applications need it too much, but you could get up to 600 megabits per second. With Wi-Fi 6, you can go up to almost 10 gigabits per second. So it's huge improvement. But if I really look at most of the IoT devices, they don't need that. Most of the IoT devices may need in the range of 1 megabits per second all the way up to 10 megabits. Some may need up to 40, 50 megabits per second. So that's good enough. But what it does is it improves the robustness. That's the more important part of it. So you can get higher throughputs at a longer range and the connection is more reliable. So that becomes very good user experience, I would say.
Yeah. Okay, so taking all of that into consideration then, what challenges do engineers face, when integrating Wi-Fi 6 into existing networks and products?
So in reality, Wi-Fi 6 is no different from any other Wi-Fi. So from an integration point of view, if I have to do a Wi-Fi integration, the challenges faced in Wi-Fi 6 will be pretty much similar to Wi-Fi 4 or Wi-Fi 5, right? Again, it depends on what kind of design you are trying to do. If you're trying to do a, let's say, wireless sensor design, you're trying to do a wireless video camera kind of a design, right? These are two different challenges. Sensor needs very low throughput, camera design needs high throughput. So from that point of view, the really system level challenges will be there, but the challenges are no different between Wi-Fi 4 to Wi-Fi 6, I would say, for an IoT device per se.
Okay.
And you need to really make sure that the network itself supports Wi-Fi 6. If you have a mixed network of Wi-Fi 6 and Wi-Fi 4, you may not really get the optimal performance out of Wi-Fi 6, but certainly you will get better performance.
Fantastic. So let's talk about the product that you've brought along today then, which is the SiWx917 Wi-Fi 6 SoC.
Sure.
So tell us about its key features.
Sure, absolutely. And before that, I just want to show this kit here. I don't know whether everyone can see that. This is the kit for 917 that we have. And this 917 supports, this is in fact a perfect device for a low power IoT applications which need Wi-Fi connectivity. So it has integrated Wi-Fi 6 in it. It has integrated Cortex M4 processor in it. It has BLE integrated for commissioning purposes, for integrating to sensors and some other devices as well. So from a user point of view, if I'm designing an IoT device, in reality, I should be able to run all the applications in it. So it has a dedicated core which is running all the stacks in it. So all the wireless stacks, all the networking stacks, everything is running on a multi-threaded processor, which is tuned for wireless applications. So in reality, the consumer, whoever is the designer, does not really see any impact on the processing power because the designer has a separate dedicated core which is running the application. So that could be running on a free RTOS kind of an operating system. The customer can be running the application over there and get all the necessary Wi-Fi, Bluetooth features which are required for an IoT device. So, and from a power point of view, we are the leader in the market. We can beat anyone in the industry today. For example, I'll give you a simple thing like a smart lock kind of an application. With this device, you can get almost in the range of about 1.5 to 2 years kind of a battery life, which is huge. And the previous, in fact, generation solutions could offer maybe in the range of 3 months, 4 months. So you're talking about 5 to 6x improvement over the other solutions in the market. That's huge because you don't have to really go and keep on changing the batteries every time, right? You don't really want to be in a situation where every 1 or 2 months you go to the door lock and change the battery. Not a good user experience, right? So with this, you can really do that as well, right? So with a standard maybe AA kind of 2 AA batteries or 3 AA batteries, you should be able to get that as well.
Fantastic.
And similarly, what we have done is you have really improved the battery life for a lot of other applications as well, right? Because previously, people never used to think of using Wi-Fi in a battery-operated device. They were thinking, okay, Wi-Fi always consumes more power because it has a very high throughput, it's going to consume more power. That's not really the case. With our solution, we can provide a very, very low standby current. What that really means is your device will be connected to the network, but it's going to be consuming extremely low current. Because most of the IoT devices today, they don't really transmit every time. Right? So for example, if you're doing again this doorbell is not going to be active all the time. Maybe somebody is going to come and press the doorbell 10 times a day, and that's maybe on an active day, right? So that's really, from that point of view, what we have done is we have brought that current to a very low level so that the device can stay connected. Okay, so you don't really see the latency. You don't want to be in a situation where if you press a button, it takes a few seconds to respond. No. So it's always connected, but it's not consuming the power. So that way we are reducing the energy consumption of the system. So within the chip itself, we have a huge number of techniques which we have used to optimize the system level power.
Fantastic.
That's what you've done.
Fantastic. So that's obviously one of its sort of main key features, but what sort of technological advancements would you say differentiate it from perhaps similar products on the market?
So going back to, of course, power is one huge thing.
Yes.
So we have reduced the power significantly, few times as compared to some of the competitors right now. That's huge, and that really required significant changes to the hardware architecture, the software, the way we are doing software. That's one thing that we have done. Integration is another thing that we have done. So we have two processors in reality in there. One processor is dedicated to the wireless and the networking side of things, and so that the user can have a dedicated processor for running all the applications. We have integrated BLE in there because which can be used for commissioning purposes as well. So if I'm a designer who wants a Wi-Fi plus BLE solution, I want to really run all the application on it, it has all the capabilities in it. And in fact, we can also interface with external processors if somebody wanted us to do it. So we can interface with the Linux processor, a processor which is running RTOS. In fact, in our booth, we are showing a reference design of a camera. Where we are running a complete security camera using this 917. Okay, and there's a camera sensor over there. So we can do a very high throughput application as well. We can do ultra low throughput application, providing much higher battery life. So depending upon the requirements of the customer, there is a flexibility provided to the user as well.
Yeah, fantastic.
And on top of that, what we have done is really we have integrated this into the complete development environment of Silicon Labs. So Silicon Labs is a development environment which everyone is used to, because everyone, we have Bluetooth products, we have ZigBee products, Z-Wave products, all of these products use the same development environment. So from a user point of view, they're getting the same developer experience which they are getting with our other products. So that way it makes it very easy for them to integrate into their system.
Yeah. And tell me more about how the SoC facilitates the deployment of Matter over Wi-Fi.
Yeah, Matter is an interesting standard. Of course, what is happening is earlier there were a huge set of problems, right? I don't know if everyone has been tracking Matter. It used to be called Project Chip earlier. Project Chip became Matter, right? So the problem is we have multiple ecosystems at home, right? So you have Google ecosystem, you have Amazon ecosystem. So onboarding a new IoT device always used to be a big challenge, right? So with Matter, they are unifying all of those things together. If somebody is supporting Matter, in reality, you should be able to onboard an Amazon device, you should be able to onboard a Google device without really any problems. So that's something which is huge and which is pretty unique to Matter. So from 917 point of view, what we are doing is we are supporting Matter over Wi-Fi inside 917. So we are providing the necessary Matter stack to the users, using which they can really develop all the applications. Okay, for example, like we were talking about this video camera or a doorbell application, right? So there people can use Matter. So in fact, onboard a particular device, control a particular device, right? So that's something which is huge, because we believe that Matter in a home environment and industrial environment soon is going to become pretty important. It is already important, and it's going to become more and more important.
Yes, definitely. So you've already mentioned, obviously, sort of the smart home and smart locks and doorbells, but what are sort of the main target applications for this product, and how does it support the current solutions in this, in the area?
So again, Wi-Fi, the number of applications is diverse, right? So we are focusing a lot on home applications and life applications. I talked about some of the home applications, like camera is there, doorbell is there, sensors are there, right? So a lot of those applications are there. We have a lot of life applications. You can have, for example, people could be using it in a Bluetooth kind of a device as well, some Wi-Fi connectivity that can be used as well. A lot of industrial applications are there. We have industrial sensors which could be sitting around. There could be some, in fact, gateway applications along with some other wireless devices that we have as well, right? So use cases are huge, in fact, right? In smart cities, there are applications as well. People are using it for pet tracking, for example. So you can have a pet collar, okay, and then you can, because it's low power, you don't really have to go and keep on changing, kind of charging the pet collar again and again, right? So they're pretty interesting applications from that point of view. So because it has low power, so we have enabled the people to use it in battery-operated devices. And as you know, battery-operated devices, number of devices are increasing every day. And they can use Wi-Fi connectivity now, higher throughput Wi-Fi connectivity, where they could not do that earlier, right? With either ZigBee or Z-Wave or Bluetooth, the throughput becomes limited. The range in some cases becomes limited as well, right? But in this case, you are getting the range, you're getting the throughput, right? So you're getting a good experience with Wi-Fi with the lower power.
Definitely.
So we are enabling a lot more applications.
I certainly need that to track my cat to see what he gets up to.
Absolutely.
Okay, so tell us more about the support that Silicon Labs offers for developers in integrating the 917 series in their products. What development tools and software support do you offer?
Sure. So development really, if I look at it, can be broken down into availability of chips and modules, that's one part of it. Second part is availability of kits.
Yep.
Third part is really the tools which are needed. Maybe reference designs is another one, right? So these are different components, right? So let's talk about one at a time here. So we do have different ICs, different modules. With modules, people, in fact, becomes very easy for people to integrate, because what happens with the Wi-Fi kind of a solution, you have to go through a lot of certifications. So at a system level, we have to go through all the regulatory certifications, which could be like FCC, ICC, right? So all the country-specific certifications are there. There are protocol compliance related stuff as well. For example, Wi-Fi is there, BTSig is there. So then for Matter, there's another one, which is Matter certification. So if you're using a module, a lot of these certification part of is taken care of. So that's, we are providing different ICs, different modules, enabling the customers. That's one part of it. The second part of it is really, as I indicated earlier, it's integrated into the toolkit that we have, which is the Simplicity Studio.
Yeah.
And in fact, we have different options for the user. For example, if a user wants everything integrated inside, so we have an option where Wi-Fi stack, the networking stack, all the way up to cloud connectivity is integrated inside. So all the user has to do is focus on the application side of things.
Yeah.
And that application could be running on our internal core as well, right? So that's one. So that has simplified the process. Second one is that the user says, okay, I'm already using an external microcontroller. So we have an option to do that as well. So we can have all the networking stack, wireless stacks running inside, and the user could be running the application on the external microcontroller. We have a third option where the user says, okay, I want the networking stack, the wireless stacks, everything running on my processor because I have a big Linux processor. So we have that option available to the user as well.
Okay.
So we have multiple options. Then on top of that, we also have kits.
Yep.
Different kits available because you got to test it out. All of that stuff is there. So, and plus, on top of that, we go through a lot of interoperability testing internally, because when you're trying to deploy Wi-Fi, the biggest problem that you see is because everyone has to interact with multiple access points. Every access point could be different. So, for example, let's go back to a pet caller application, right? So that could be deployed in a home which could be using one access point. That same thing could be deployed in another room which is using another access point. The issue is this Wi-Fi device has to work with all of these access points. So we do a lot of that interoperability testing internally to make sure that people do not run into any of these corners. So that's another thing that we're doing. On top of that, we also have reference designs. So in fact, that's one thing that I talked about. So there's a camera reference design that we've created, which people can use for creating their own camera applications as well. And finally, of course, we have partners like DigiKey. They're helping us out in really kind of promoting this solution to the end customers. Right, so that's something which is very important. So we need to make sure that we are reaching the end customers, right? So that's something very important. So we have DigiKey, multiple other partners in different parts of the world who can help out in kind of figuring out what is the right solution and also making sure that they get integrated properly into the end system as well.
Yeah, okay. Can we expect any sort of further developments or product launches from Silicon Labs in this area?
Oh, absolutely. In fact, so we are actively working on Wi-Fi. You'll see a lot more announcements coming from us. So we had Wi-Fi 4 solutions earlier. So we had the WF200, there was another 9116. Now we have 917, which is Wi-Fi 6. So Wi-Fi 6 is the leading edge right now on IoT side. So as Wi-Fi 7 comes in, Wi-Fi 8 comes in, right? So we will certainly have announcements over there. So this is a big focus area for us as a company, because a lot of the IoT devices are going to use Wi-Fi, and we need to make sure that we provide the necessary solutions. And we are also going to couple this with our other wireless solutions, because somebody may be wanting a sub-gigahertz along with a Wi-Fi solution. So we have sub-gigahertz technologies as well, and we can couple them together to create a complete solution for the end customer as well. So that's something that's going to happen. And in fact, in this show, we are also announcing another product which we are calling it XG26, which is really meant for Matter. So we have increased the memory over there, more number of GPIOs, right? So which is a perfect device for anyone who's developing Matter over Thread. That one does not support Wi-Fi, but you can use it for Matter over Thread kind of application, right? So that's a perfect device for it. So we are innovating on all the different wireless standards.
Yeah, certainly watch this space. It looks like you're doing great.
Thank you.
Brilliant. Well, thank you very much for your time and insights today. It's been a real pleasure. And I encourage anyone to pop by the Silicon Labs stand while they're at Embedded World. So thank you very much.
Thank you, Paige, for having me here. Okay.
Thank you.
Thank you.